Section 4.3 is about succession. And if you think of the word succession, if something happens in succession, it happens one right after the other. We're talking about ecological succession here, which is predictable changes that occur, or more or less predictable changes that occur in a community over time. So what happens to an ecosystem as it ages? Especially after disturbances, you see some changes. You have species dying out, new species filling those niches. Over the course of succession, biodiversity gets greater. The number of different species present tends to increase. Primary succession is when you start out with nothing, no soil. Primary succession. An example is after a volcanic explosion. Lava flow creates new land or sterilizes existing areas. Retreating glaciers, is another example of where you have exposed bare rock only. This has happened in Glacier Bay, Alaska, by way of a retreating glacier. Scientists have studied this area for more than 100 years. And now there's a hemlock and spruce forest found in the area. And it's not done. Changes will continue to occur. The first species to colonize these barren areas in primary succession are called pioneer species. One of the most common examples of a mutualistic symbiosis between algae and fungus is lichen. It grows on bare rock. So that's frequently the pioneer species in primary succession. Lichen will convert or fix atmospheric nitrogen into useful forms for other organisms, break down rock, and add their own organic material to form soil. Grasses, like those that colonized Krakatau, which is a volcanic island, are also pioneer species. Secondary succession is where communities aren't completely destroyed by a disturbance. It proceeds faster than primary succession because there's soil. Soil doesn't have to be formed. So new and surviving vegetation can regrow rapidly. So the timeline here you see with secondary succession is 40 plus years. Whereas if you look at the timeline for primary succession, it's over 100 years. Secondary succession follows a wildfire, hurricane, or other natural disturbance. It's interesting because we think of it as a disaster. Many species, however, are adapted to them. Fire can stimulate their seeds to germinate. And other species can fill in the niches. It's actually a natural process. People who are in charge of nature centers will do what are called controlled burns. They actually, on purpose, burn land to start this succession because overgrowth is a bad thing. Secondary succession can also follow human activities like logging and farming. This is in the Carolinas, the Piedmont area of the Carolinas. You see this happening in abandoned fields. Over the last century, they've matured into oak forests. Why succession? Well, every organism changes the environment it lives in. One model says as one species alters its environment, other species find it easier to compete for resources and survive. This is in the example of primary succession with the lichen. They form the soil, and then mosses and other plants can grow there. Organic matter accumulates when these organisms die. Other species move in and change the environment further. So as we get this spreading of species and more organic matter added to the area, there are more niches and more places for species to survive. Previous theories were that succession always would go through the same stages to produce a specific and stable climax community. That climax community is the ultimate, the biodiversity, the ultimate ecosystem in an area. But other studies now have shown that succession doesn't always follow the same path, and climax communities aren't predictable in their outcome. Secondary succession in a healthy ecosystem can reproduce often the original climax community. Coral reefs and tropical rainforests that are healthy can recover from storms. Healthy forests and grasslands can recover from wildfires. But like we said before, some climax communities are not uniform. There are areas in varying stages of secondary succession after multiple disturbances that took place at different times, and some climax communities are disturbed so often that they're never stable. Where we see succession not very successful, so to speak, is after human-caused disturbances. Clearing and farming of tropical rainforests can change the microclimate and soil so much that the original community can't recover or regrow. So human-caused disturbances do not necessarily guarantee that succession will proceed the way it should. You won't get the original climax community after human disturbances. Ecologists study succession by comparing different cases, looking for similarities and differences. Mount St. Helens was a volcano that erupted in the Pacific Northwest in 1980, and they may have also studied Krakatoa, the volcanic island. What researchers saw is that in both places, primary succession proceeded through predictable stages. The first plants and animals that arrived had seeds or spores, or adult stages that traveled over long distances. These hardy pioneer species helped stabilize loose volcanic debris, helped later species to take hold. These studies confirm that succession in terms of primary succession is slow, and that it's chance. Determining which species colonize at different times, it's completely up to chance. What seed lands, what spore is carried in the wind.